The topic we want to cover today is hypothesis testing. And hypothesis testing is one of the most important parts of statistics, and we use probability theories as well as statistical measures to test a hypothesis. So we will learn what a hypothesis is, and we will learn one-tail, two-tail test of hypothesis, and we're going to talk about type 1 and type 2 errors. And also you will learn about the steps of hypothesis testing. So what is the hypothesis? A hypothesis is a statement about the value of population parameter developed for purpose of testing. So let's say you have a population, we conduct sampling, and from the sample we get an average. This average is the parameter of the sample. So we're going to use the parameter of the sample to estimate the parameter of the population, and we want to bring a general rule based on that for population parameters, saying there is a relation or there is a difference, and so on. Okay, so that's, in fact, if we want to talk about hypothesis testing in a very simple word, we can say it's guessing, right? You guess about something and then you provide statistical or numerical proof for it. And hypothesis testing is the procedure based on sample evidence and probability theory used to determine whether the hypothesis is a reasonable statement and should be rejected, or is unreasonable and should be rejected. So these are steps of hypothesis testing in general. So we always start with stating the null and alternative hypothesis. So we will say what is our hypothesis. So how do we start writing a hypothesis? We normally use a small sample, and using the small sample, we get some averages, we get some information, some statistical measures. Based on those statistical measures, we come up with a guess, a hypothesis, right? So if average of two groups, for example, groups of male and female students, and we want to know if there is a significant difference in regards to their average grade. So what we are testing here is, does gender, being a male or a female, have anything to do, any association with student grades? Or is there a significant difference between male and female regarding their grades? So what we do, we get a small sample, we get the average of male and female students, and from that average, we can see if this difference exists or not. So if they are exactly the same numbers, exactly the same average grades, so we can simply say our main hypothesis, an alternative hypothesis, which is always written in the positive form, will be there is a significant difference between male and female students regarding their grades. And if on that small sample that we have, we can see that there is a difference, right? I can say 99.9% of cases, when you want to find some averages on groups, there is a significant difference. So there is the difference. So we want to prove that this difference is significant or it's not significant, okay? So where hypothesis alternative comes from, it comes from that, from the initial sample that we take. Now, the next step is to determine what significant level we're going to use. The significant level is, in fact, what we also call it the part that the error, the maximum error possible for our calculations. So, in other words, let's say you have a manager, and your manager is saying run a hypothesis to see if there is a significant difference between these two groups of car we are selling in average price or in average age of customers, right? So your manager can also determine how significant, how accurate he wants you to be. So if he says, don't have more than 5% error, or if he says, you should not have more than 1% error, that 1%, that 5%, that is a significant level provided by the manager. In this class, is normally provided by a question. By default, for business, we use a 5% and jump, and also other softwares like SPSS, like Stat Graphics, they also consider 5% as a default. So normally there's an option on software where you can just click and change that 5%. So when your significant level is given, we represent significant level by alpha, and we always say alpha is 5%, alpha is 1%. So that is the maximum. That is the maximum error you can have when you are making a decision on hypothesis test. Okay. If I tell you significant level is 5%, what is the confidence level? 1 minus significant level, 1 minus alpha, that would be your confidence level. So if I give you alpha 1%, then your confidence level would be 99%. 1 minus 1%, 99%, right? So it's always 1 minus significant level is confidence level. For some problems, they will give you the confidence level required. If they say 95% confidence level, what would you do? 1 minus 95%, that's alpha, that's your significance. So this is the second step. So we always want to know what the hypothesis test is, and then we want to know what the significant level is. Knowing these two will help us to go to the next step. The next step is to identify what test to use. Which test is the best test to run in a certain case that we are working on. And can we always use the same test? No. There are many statistical tests out there that we can use to conduct research and find and make decisions and find more information about statistical measures. And it really depends on the question. It really depends on the type of variable we're working with. So depend on what type of variable, what type of problem we're solving. Is this about association relation? Is this about differences? So that would put us in a different situation regarding the test that we have to use. Okay, so let me give you an example. If we have normalized data, and for this normalized data, we are going to see association between two quantitative continuous variables. So if we have relation between two continuous variables, this is hypothesis test of relations. No matter what the significant level is, we're going to use correlation. We're going to use regression analysis, right? If it's about group analysis, meaning that we're going to see difference between groups, groups of, for example, buyers, home buyers. We have groups, education groups, 5 education groups. We have 5 different groups of age. We have 5 different groups of, for example, salary, right? These different groups, we want to see in average how much they have bought, or what's the average salary, or what is their average, different categories, right? For differences, we use a different method. We don't use correlation, we don't use regression, we use, for example, ANOVA tests. We might want to use ANCOVA test, depend on what type of variable, what group variables we have, okay? After that, we need to come up with a formulating our decision rule. So formulating decision rule, I can say it's almost clearly the same for all hypothesis testings. In general, we want to know in what situation are we going to reject H null, and in what situation we're going to fail to reject H null or accept HA, right? So for that, because the significant level is given to us, it's pretty much easy. We will reject HO or H null if the p-value is less than 0.05. So I will talk about that, but I can say for 99% of hypothesis tests that we will run in this course, we always have this situation. If p-value is less than 0.05, we're going to reject HO. There are other ways to make that decision, but in a general form, we can say p-value is the safest and easiest way to understand to reject hypothesis or fail to reject hypothesis. And then at the end of the work, we run the test, we come up with the p-value, look at the confidence interval, check our tests, and decide to reject HO and accept HA or H1, or do not reject HO, okay? So HO or null hypothesis or H0, so different books, they have different formats. So you're supposed to know all of these, HO or H null or H0, and H1 or HA or hypothesis alternate hypothesis, or H1, right? Remember, H1 normally, when I say normally, 99% of cases, I can say H1 is written in a positive format, which means we say there is a significant relation, there is a significant difference. And H null is normally written in a negative form. There is no relation, there is no significant relation, or there is no significant difference. A random sample of size n is used to reject HO. If we conclude do not reject HO, this does not necessarily mean that the null hypothesis is true. It only suggests that there is not sufficient evidence to reject HO. So our job, based on the results of hypothesis testing, is to reject HO or fail to reject HO. So if we cannot reject HO, if for any reason the p-value is not less than 0.05, and as a result we can't reject HO, right? So as a result, when we say do not reject HO, what that means is not we are not actually accepting HO. Why is that? That's because HO is that 5%. HO is based on that 5%. And we do not want to accept anything based on 5% of our population or based on our 5% sample. We want to make decision based on 95% or the majority, like 99%, 95%, which is our HA. So HA, we can accept it. H null, we can reject it because it's the minority. We can reject it, but based on minority, if we could not reject, that does not mean we are accepting HO. So there are type 1 and type 2 errors in hypothesis testing. So let's say we come up with a decision to reject HO. If you decide to reject HO, this is HO, right? This is HO. If you decide to reject HO, you are rejecting HO. Rejecting HO means you're saying HO is not true. However, let's say HO was true. So whatever we write for HO, there is no significant relation, there is no significant difference. Whatever it is, let's say in reality, it is true. And based on statistical results, based on p-value or the confidence interval, we decided to reject HO. So that's a mistake because we are rejecting something that is true, right? If HO is true and you reject it, that is type 1 error. If you do not reject something that is correct, that is a correct decision. Now, the opposite of that is, let's say HO is false. That means HO is not true, right? And let's say we do not reject it. We're supposed to reject something that is not correct, right? So if we do not reject it, that is called type 2 error. So type 1 error and type 2 error. These are important to remember that these errors exist. There are a couple of reasons that these errors can happen. Things like lurking variables, things like small samples, things like the way that data collection was performed was not random. It was in a wrong way of data collection, or sometimes it's related to the question that the survey that you create and give it. There could be misunderstanding on some questions. So those can lead to type 1 and type 2 errors. We won't really spend much time on understanding the type 1 and type 2 error. That's for a higher level of statistics. But knowing that even statistical results may have errors involved is good to know. It's good to know that if your sample is not collected well, if you don't have a big sample, if you don't have a randomly collected sample, if you don't have your questionnaire designed in a scientific manner, these are reasons that your data can be less reliable, and as a result, that bring you to some errors in decision making. So what are the critical values? The critical values are actually very important in statistical testing. So let's say that this is a normal probability distribution that we did discuss that earlier in the past weeks. And you know that the standard normal distribution convert or transfers the average of your variable to 0. So z equal to 0 in the middle. To the right is showing the values higher than average. To the left, values lower than average, right? So that area under the curve is always 1. That area in the middle, that's your 95% or 99% confidence level. And that small portion on 2 sides, or sometimes it's on only 1 side, that is your significant level, right? So the question is, how many standard deviation away from the center will give us that cut point between the confidence and the significant level, or HA and HO. So this is HA area, this is HO area, right? This is where HO values are. This area is the bigger area. Majority of our data are here, right? 95 or 99% of them, they present here. So those fall in the middle. Those errors fall outside. HO falls outside. So the question is, how many standard deviation from the center would give us that borderline? That borderline and how far it's from the center, it's called critical value. Now, if the error is less than 5%, meaning that that interval is expanded and falls outside this area, outside that center area, that means we have less error. If you have less error, you can reject HO. If you have more error, you fail to reject HO, right? So that's basically that is what in general p-value means. So what's the definition of critical value? A critical value is the number on the borderline separating sample statistics that are likely to occur from those that are unlikely to occur. So likely to occur are the majority, unlikely those are small 5% or 1% on the significant area. The number z of alpha half is a critical value that is a z-score with the property that it separates an area of alpha half in the right tail standard normal distribution. And I think that's pretty much well explained here. So that's your confidence level of 95%. If we use 95% on a normal distribution, we can see, do you remember we said that almost 2%, approximately two times standard deviation away from the mean, 2 times standard deviation away from the mean includes 95%. Do you remember we say 3 times of it includes 99.7%? This is almost the same thing, right? 1.96 is almost 2, right? Almost 2. So 95% of observations are between Z plus 2, Z minus 2 standard deviation, right? And that 5% left, so 95%, 100 minus 95% is 5%. 5%, it divides on two sides. We call it tails, two tails. Each one 0.025 or 2.5% on each side, right? So these are significant levels. These significant levels are created and provided by your manager or by the question. We put it together, that's 5%. That 5% alpha level is determined, is given to you. What is it? Maximum error acceptable. If your error is more than 5%, how do we calculate the error? That's p-value. If p-value is more than 5%, if is more than this error and comes inside the confidence area, then we cannot reject HO. We're supposed to reject HO, right? That is a good way of the hypothesis testing can go. That means we reject HO and we say there is a relation or there is a difference, okay? But if that doesn't happen, if the critical, the p-value is more than 5%, this line falls to the left, and as a result, we cannot reject HO, okay? Okay, we're here. So not every hypothesis testing has a two-tail. Some of them, they're right tail. So what's the difference between the right tail, left tail, and two-tail hypothesis tests? So it's all about the wording of the question. So if the question says, there is a significant difference, or HO says, there is no significant difference, are we giving any direction to difference? Are we saying which group is more or less, faster or slower, higher or lower? We're not saying. If we do not say any direction in our hypothesis wording, if there is no direction, we're not saying greater than, this group is better than, this group spends more than, less than, right? That is two-tail. If we do not say any direction in our hypothesis words, that is two-tail, because we're not determining left or right, more or less. That makes it, there are two possibilities, could be more, could be less, that's two-tail. So this case is a one-tail. One-tail hypothesis tests are normally very straightforward. The question says the group of male students have lower or higher grade compared to female groups, right? Or age of customers who are at the PhD level, they have a higher age compared to younger ones or the ones with a bachelor degree. So this comparison is exactly saying which group is higher or lower than the other group. That makes it the right tail or left tail, one tail, right? So if you have one tail, could be right or left. Left is normally for the words like less than, lower than, slower than. Right is normally for higher than, faster than, better than, right? So if those words exist in hypothesis, that's one tail. If it's a higher, more, that's right tail. If it's a lower, less, that's left tail. So you can see all three types of hypothesis on this slide. So that's a two-tail, 95%, 1.96 is the critical value. That's a left tail, and that's a right tail. And these are the way that we can write hypothesis on group analysis of average. So if we are comparing averages of groups, right? So H1, if it's saying that mu is not the same as, mu is a population average. Population average is not equal to the samples average, versus opposite of that is a null hypothesis, which is saying population's average and the average of the sample are the same. And what's the condition to reject HO? We reject HO if Z from the test. So where do we get the Z value? There are averages, right? Standard deviation and sample size in the question. We just substitute in these formulas, depend on the type of question. We substitute X bar, mu, sigma, and N, sample size, into the formula. Z stat is given. So if Z stat, absolute value of Z stat is more than Z critical, we will reject HO. This is what it's saying. It's saying reject HO if Z stat is more than Z critical, which is that borderline. So Z critical is that borderline. If the Z stat is outside that range, that means you have less error, you have more confidence. That is good. That means you reject HO. If that does not happen, the Z stat falls somewhere here, less than that critical point. That is the critical point. If your Z stat falls on the left, area to the right-hand side of it is your p-value. P-value is more than the significant level. And p-value is the error of the test, right? The error that we calculated is more than the 5% that we were given. It's more error, that means you cannot reject HO, right? And that's the same for left or right or two-tail hypothesis tests. All right, so this is saying the same story, but for problems with proportion. So if proportion is given to you, the formula of Z is different. If mean and standard deviation is given to you, sample size, that's the formula we use. For more than 30 sample size or for data that are normally distributed, we use Z. If they don't follow normal distribution or small samples, we use T distribution. For proportion problems, we use Z distribution. We almost never have to use these formulas for this semester because JUMP will calculate all of these numbers for you. You don't need to work on any of those. So I'm just moving on. So in this case, we have a hypothesis test here. We don't want to go through the details of the hypothesis, but let's just look at here. So what we see here is we can see that there is a 99% confidence level is provided. So the question is asking, using significant level of alpha 1% used for hypothesis testing. Now, we calculate for 99%, it's not 99.7, it's 99%. For 99%, Z value will be 2.58. So that border, that's our critical value. So associated alpha level to 2.58 is 1%. So that's significant level, alpha is 1%. Now we are given average of the sample, average of the population, we are given the sample size, and we are given the standard deviation. We just plug in these numbers, and if that Z stat, the Z stat that we calculate is more than critical value, that falls on the right-hand side. If it falls on the right-hand side, that means you have less error because area to the right of it is smaller than 5%, right? But in this case, you can see that the Z stat is 1.55. It's actually less than that, right? So what is the p-value here? P-value is all the area to the right-hand side of that line right here. So our significant level was supposed to be less than 1%. That's less than 1%. That's 1%. Is this area less than or more than 1%? That's more than 1%. That means our decision on the error, our error on this decision is more than 1%. As a result, we cannot reject HO here, okay? So because 1.55 does not fall in rejection region, HO is not rejected. So we do not reject HO, okay? So we can always talk about critical value versus Z-stat, but it's much easier to use p-value. Yeah, so if there is a question about how to use jump on that, I will get there. So let's just complete the theoretical part first, then we will talk about jump as well. Every hypothesis testing in jump, all the tests in jump, they provide p-value. As a result, it's actually very easy to look at p-value on the results of jump and easily recognize to reject HO or fail to reject HO. So the main reason we went over this up to this point was we want to make sure you understand what a p-value is. So p-value compared to significant level. Significant level is the maximum error you can have. P-value is the error that your calculation, your hypothesis testing is giving you. So compare it. Is your p-value less than the significant level given? Then that's perfect. Is your error less than 5%? That's perfect, reject HO. If not, fail to reject HO. Okay, so let's move on to, so this is type 1, type 2 error again, same topics. And that's a p-value. So what is p-value in a statistical definition of p-value is? P-value is the probability of observing a sample value as extreme as or more extreme than the value observed, given that the null hypothesis is true, right? So in testing a hypothesis, we can also compare p-value to the significant level alpha. As a result, if the p-value is less than significant level alpha, we can reject HO. If not, if the p-value is more than or equal to 0.05 or 0.01, then you cannot reject HO. So this is, I believe, the example we just saw together. So 1.55. So we don't really need to look at the critical value and look at the Z-stat or T-stat. We just need to look at a p-value. You can see in this case, p-value, the red area, is more than the significant area, 1%. This is more than 1%, right? As a result, you cannot reject HO. So different ways that we use T-stat or Z-stat, normal distribution or T-distribution, it's normally because we either have or we don't have the population standard deviation. If you have the population standard deviation given to you, you can use normal distribution or Z-distribution. If it's not given to you, you have to use the standard deviation of the sample, which is S, and in that case, you use T-distribution. However, I want to remind you that T and Z distribution are very similar. T distribution is actually just a little flatter than Z distribution. And as a result, when you have more data, more observations, T distribution actually approaches Z distribution. Why is that? That's because the T distribution is very sensitive to sample size. So T distribution is sensitive to sample size. That is why for small samples, especially when we don't have the standard deviation of population, we can easily use T distribution. It calculates the hypothesis test for us accurately, pretty much accurately. But when the sample size is large, the results of T distribution and Z distribution are pretty much the same. If you look at the T table at the back of any statistics or basic statistics book, you will see that at the end of sample sizes of T distribution, the numbers are exactly the same as the numbers on a Z distribution.